Recording in progress.
Hello students, here we are going to start our database management system and database implementation and design course. And here, last week we have covered these things: relational database model, and after that we discussed these things, right? So how this kind of relational database model worked on different environment, different software, different database management systems are displaying the same thing in different ways. And then we discuss about relationships, again types, and we went through some examples. After that, types of relationships, and we described them in depth way, right? Hope all of you can understand these concepts by going through these examples. We mentioned about these kind of facts and composite entities and the way of representing them in conceptual model. Then, so he mentioned that, so the way that we can representing the same example in entity relationship model, after that relational schema, and after that we start this section. So then we mention about these. So what is conceptual model? Okay, how it differs from others. And we went through some examples. Then we mentioned about internal model and the different and the external model, and we mentioned differences. So then we mentioned physical model also, right? Okay, then today we have to start this section, right? Then development and AR diagram. Okay, we already learned most of points, theories related to ER diagrams. Today we are going to directly discuss about, okay, we indirectly discussed about all the facts which are needed for forming an ER diagram. Okay. But we mentioned about relational model, that kind of way we learned about the facts which are related to ER diagram. Okay, today we are directly talking about ER diagrams, that how we can developing an ER diagram by going through the beginning, right? Step by step, how we can build. So at the beginning, it is mentioned here, it is an iterative process. So hopefully we can understand what is iterative process. So iteration means what? So it is repeating. Repeating means same, not the same thing repeating, but same process is repeating, right? After complete one cycle, okay, yeah, it is going through the same instructions, okay, but maybe different data. Understood? So same thing and same way is they are different, right? Hope all of you can understand these facts. So here, this ER diagram development can be considered as iterative process. Okay, then here, so some examples are here also, right? Then so this example, then it's not example, and yeah, after then the same thing I have explained there. Okay, then process reviewing, and I mentioned about what is repeating. Okay, the process instructions are repeating. Same principle should be applied there for different scenarios, different data. Okay, then okay, today we have to, previously we mentioned that we are going to develop an ER diagram, and there is a example. Then we have, then normally we are developing an ER diagram for some kind of system. Got that? Or some environment. Or then it is related to some university environment or school or other office or other environment. Hope you can understand what are the systems or where we can apply these ER diagram related representation. So this is one example. We already discussed some related facts related to this example. Then this is so familiar to you. Then that's why we are using same example. But after that, so we are doing so here we are going to discuss additional things than we have done related to this example. Here we are discussing about again developing ER diagram to the by for the given scenario or case. Okay. Again, first we will understand this thing and understand this scenario. After that, we can go line by line and develop ER diagram. We will develop ER diagram. Read these things. Okay, then this is the example we were discussing about, and here then it is mentioning about cardinalities. Hope all of you know about what is cardinalities. So, so it is mentioning about entities like dean, faculty, and administrator, and also classes. So basically, that supertype or subtype relationship can be displayed as this way. This is not an ER diagram, but then employee can be what? Professor or administrator, and after that, so the administrative means the dean of the faculty and professor teachers for classes. So this is the overview kind of thing you can understand by going through this example, right? This example. So according to the given instructions, so we can build an ER diagram by previously I told that here we are going to build an ER diagram by going through step by step. Then here in the first case here we can display this same thing in this way. The professor is an employee, right? And in this case, after that, so professor is optional to employee. Other words, employee required to be a professor. Hope all of you can understand this, right? Here, then by going through this example, what are the things you can gather by looking at this ER diagram section? So professor has relationship with employee. Professor is an employee. So professor there might be a zero professor sometimes, but maximum one professor. And after that, so employee minimum there should be one employee, must be one employee, maximum one employee. Got that? Then here think this one, and here when we are discussing about and explaining this one, employee is a table, right? And professor also a table. So according to this scenario, okay, there is a must be a employee table. Okay, there may sometimes it can include professors, and sometimes it may not. Maybe other professionals there. Hope all of you can understand this scenario, right? Then faculty composed with several departments. Example, right? There is a faculty, and if there is faculty, you already understand there are different departments. So for the science faculty, there may be what chemistry, physics, computer science kind of departments. And we will go through this example, this scenario. So it is mentioning about some business as a business faculty and accounting and departments, economics, marketing, and accounting. And we know about cardinality rules. After that, so we can map this information. Okay, first week we'll just read and understand this example, this scenario. And after that, we can map them on map the AR diagram. So previously we mentioned this part. So here you can see here one step by step we are building the story, that means the ER diagram. And after that here, this part, he mentioned that faculty and department related example. And here, so one faculty can have multiple departments, got that? And so minimum department there should be one, multiple maximum departments there should be many. Can you put this as M? But here normally mentioned as N. Needed M also. The N and M both are having what? Same meaning. After that, then minimum faculties for department, because here understand these are tables, and also think about the given example. There must be faculty, right? According to the example. So minimum there should be one faculty. So maximum, normally you are in practical scenario also you can understand for one department there can't be what? Maximum multiple faculties. So the maximum faculty also one. So that is the way we have to so you should understand very clear way how you can map these things, how you can input these data one by one. So at the time you are learning these things, Again, yourself, you have to map and draw these things and try to understand these concepts, basic concepts. Okay, when once you understand these things, then you can apply this knowledge into any scenario and any given case. So that is the thing we are expecting you to do at the exam. Okay, there will be another case, or if there is another case, then we can link them here to here, or according to that, then we have to check. So, what is the entity, the new entity? Is there a connection with already existing entity? If it is yes, you have to link with the existing entity. Otherwise, you have to form two new entities and build the relationship. If it is existing one, you can what? Just need a relationship there and mention the other new entity. Hope you can understand. Sometimes it is adding. Most of time it is adding one by one. Then that is so. That is the thing. What I told, what we mentioned, what we discussed at the beginning. This is as a what iteration, or this has a repetitive process. Why? This is repeatedly the same thing. Huh? This kind of same kind of actions are performing one by one. Finally, you will have a what? A complex or what in detailed way. Then actually what? An ER diagram, there may be multiple relationships and more data. Then next one. The third one, third example. Please go through example and understand ER diagram segment. One part, just a segment. Finally, we are what? Linking to the main ER make a section, right? Okay, here this example. Again, one there can be one department. Basically, you can understand here. One department. So one department, then this department means department table, right? You are okay. This is department table there. Got that? Then that table has what? Multiple records. right? And after that, course or multiple courses. Got that? So you know that for courses, then multiple courses. So courses means what? And database implementation 3301. Then you know that there is what primary key there. So department also the department ID there. So you know that to build a relationship what? So that this one of so primary key should be entered into other ones as other table as a foreign key, right? Then you can make easily a relationship, right? Then if needed, you can department ID can be put here as foreign key. This is one way. There are a lot of ways for building the relationship in between the tables. After that, so one record, okay, then one department ID. So we will say department ID means science one. So science department think that it can have a department ID. That means primary key is high, right? So not science the department, right? Not faculty. So computer science. So department ID. Then that can have multiple courses there, right? 3301, 3302, that kind of things, right? Courses, multiple courses. So one department can have multiple courses. Then one row has connection with two rows or multiple rows. Then one many. So one to many. Got that? So we don't know in practical scenario. It can be one to many means we don't know one to two the or one to three or one to four. So it can be connected with four rows with this one row. Then so this one to many is meshing, right? And here it is describing as minimum there must be one course according to the given example and maximum many, and it has been used there. Then you know the course has one courses are having one department here. Yeah. So each course can have what? Each course. Yeah. When considering this one course can't we have multiple departments? Got that? So this must only connected with what? Computer science. Okay, then this can't what? Connect with chemistry department courses or physics department. So this is a computer related one. So that's why it is mentioned as what? Minimum there are also one department there and maximum one. So always these things are inserting these information are placing like the same way. So that's why we mentioned that the same process, same instructions set are repeatedly used what? Why or when you are implementing, when you are building, when you are drawing or mapping an ER diagram. The same way you have to think. So what table, why or when, then So how relationships are behaving, whether it is optional or not, what would we do when it is optional, right? So cardinality is how we can mention, right? Then finally you can add this ER diagram segment into the what? Main ER diagram. So next example, this one. So optional scenario there. Little difference can be seen there, but you can understand. Here, so main thing we have to understand here is class is optional to the course, right? Now you know these class tables and course table. So there can be multiple classes sometimes. Sometimes there may be zero classes. for a course. Got that? Then zero classes can be represent like this way, optional. So that means even without classes, so course table existing. Got that? Course table existing in where? The database. Here we are discussing how we are creating tables, how we are connecting tables in a database, right? So database software, I will show some example how database software are maintaining and how these things are stored in a database, for example database. So all these tables here, there can't be, sometimes it may be records with in class table. But the cost table, there is courses, right? And here zero classes may be there and multiple classes may be there. Zero classes mean no records. Multiple classes mean the multiple records can be will be included if there are actually, right? But each class can have what? How many courses? So that class is belong to each one class belong to what? Must belong only for one course. One course means what? So one course, we don't know what is the course. That course can be contained inside of this table. So that can be that can be database implementation or networking or other kind of course. Or then you can understand these relationships are building with mainly with tables, but we have to think, okay, we should understand. So record wisely how they have connections or relationships. They hope it is clear to this case also. And this next one, a little bit more information can be seen there. So two different things, chairs and assigned to two different meanings are there. So here we have break some given scenario into say multiple sections, and we are forming ER segments one by one here. Then what would be our final goal? So we have then finally we can build complete ER diagram. Read these things and just understand the way that how it is building, or you can practice yourself by drawing in a paper or other kind of way. You can practice these things. So practically then the theories are just theories, right? You have to practically or do these things and do these activities. So here this explanation, then these are the most important thing. The department has many professors to assign it, right? Then after that, only one of those professors chairs the department, right? Maybe like the head. Then after that, and only one of professors can chair the department to which he is assigned, and no professor is required to accept chair position. And therefore department is optional to professor, right? So each professor is assigned only to one department, right? Then professors can't, if professor is assigned to department, he can't involve or assign to multiple departments, right? So, but one department must have what? Yeah, each department can, there should be at least one professor. Got that? At least one professor. Then there can be multiple professors. Got that? So multiple professors for one department can be displayed as that way. So one department means this one, right? So one professor can teach only one department. Got that? So chairing means this one previously we mentioned. So one professor, one department. Okay, then the professor may, so optional chair scenario. One chairs in one department has one chair, that means a professor. So you can see here the way that relationships are building with these terms, right? So these are related to verbs. Chairs means what? Again, a verb related thing. Normally, most of time we are mentioning these things in simple present tense. Trying to. Then next example. So professor teaching in classes. So here then important thing you can understand here, this part, cardinality. We then understand these things. So minimum can be 0 professors, then maximum, then classes, right? So classes, professor can teach So one class, the class is optional here. And 0 to 4 classes can be then we mentioned that relationships are building the one-to-many relationship. Okay, then it can be formed up to 4 records, right? In a 4 class records. So one professor can have. So there may not be relationship with records this professor. Then other thing is for one class. So then there must be what? One professor. So then minimum and maximum professors. So minimum 1. So maximum 1 for each class. Here this is a professor teaching scenario in classes. Now you can understand these things yourself clearly. Right? The next one, composite entity. The many to many actually then a little bit important than previous one. Again, new thing there. Then go through these things and understand these concepts. Okay, then this example, classes. Student may decide to take 5 classes: statistics, accounting, English, database, and history, right? And student may enroll up to 5 classes, and each may have up to 35 students in this, creating many to many relationship. Very important. So multiple students, multiple classes, got that? And what does it mean? One record of student table can have uh, multiple relationship with multiple records of with classes. Got that? And other way, so in one class, there can be what? For one class, then there can be what? Multiple students, the relationships in between. Understood? So that kind of scenario is going here. And other thing you can understand, then optional related information also contains here. Right? So what does it mean by optional case? Then here, class can exist at the start of the enrollment period. Got that? In the database, it is building a class table there. When university advertise or marketing or that at the beginning, a class table creating, got that? But so sometimes there may not students, but student table also there, but student what records may not there. So that's why it is mentioned as what? Student is optional to class. So very important here. So when you are, then you know that when displaying many-to-many relationship, normally you know that we can't represent many-to-many relationship in ER diagram in this way. Don't do that, right? Wrong. Must use what? This format. This concept we learned. Composite entity related things, we know them, know it, and you have to apply that knowledge to building. Actually, when there is this kind of many-to-many relationship, okay, you have to convert that into this kind of the same many-to-many relationship, but it is representing in different way. So one has many. So this is the basic thing. One student can have multiple enrollments, and one class have multiple enrollments. Got that? Then a student is optional to the classes. Student optional to classes can be represented in this way. But that the very important here when you are using composite entities, then that optional mark comes to here. Okay, the previous one, can you compare with the previous things? When student is optional to class, right? Then that means this circle notation is normally mentioned at this side. So optional, then who is the optional? Then circle goes to that place. Then when you are considering one to many or many to many, many to one to many or many to one, that means one to many relationships. Hope you can relate. Recall this example. This related. This we discussed already, right? And but this when you are dealing with composite entities, while there is this kind of relationship, so you have to be careful to place the optional symbol at this place. Got that? If if that student enroll with the class, so with program or class, then so one student at least follow registered with enroll with one class, maximum 5 classes. Got that? So one for one class. So there may not be registered student. That's why I mentioned as 0 there. Then but for one class, then class can be identified as class ID, right? So one class may include must okay maximum there should be only 35. Got that? If there is enrollment, there should be one class, and if there is a student enrollment, there should be one student. Then next one, and this example, go through this example, right? Here someone again asking us 1 to 5 means here only the one many minimum there should be student can register with one classes and maximum 5 classes. And here this representing there may not registered students and maximum 35 students. Right? So this case, one, and this one you will learn that later sections. And here, just we are focusing these things. And here and this scenario, and go through this example. Then this one department can have many students. One student can only have so one department according to this one. So here the scenario, then each student has only has single major, and we can consider as associated with one department according to this given example, right? Not other practical examples. We are discussing about the given example, right? So minimum one, maximum one, right? So here department, so there is a minimum one student on each department can have multiple students, maybe 100, maybe 1,000, right? So that is the way we can represent the same example in this ER component section. So one department, multiple students. Right here, this describes about department. This describes about a student. Here, this is described about uh, all student. Here, describe about what all department, minimum and maximum count. Can you understand these things? Very simple. So we mentioned repetitively we are using this approach to build an ER diagram, right? And this one is the last section, last component of the given scenario. And professor advises student. Again, you can see here what one to many optional one, right? Student is optional, but there may multiple students sometime, or sometimes there may not students. Can you understand? And when counsels for students, so one student can only have one professor. What that means, for this is information related to professors. So there should be what? Must be one professor there. Okay? Can't be zero, can't be multiple, right? So you can understand these things. So think these things according to tables and table records and relationships, as I mentioned, as I explained in some previous example sections, right? Then apply and understand deeply, and after that, just after these lessons, try to draw ER diagram yourself. Then only you will be realize actual relationships, and you will be improve the skills of developing ER diagram according to the given scenarios. Okay, so that would be challenging when you are trying to do these things yourself. But when you have, then now you have more time before your CAT exam and other final exams, then take some time and spend more time regarding to these activities. Okay, then so this is the summary. So we learned about some example sections of given main scenario. So they can be summarized as this way. Got that? So entities, relationships, and connectivity. Then we know that these kind of many to many relationships, we so student class many to many relationship is displayed a little bit different way than others one to many. Then most of uh, relationships are one to many relationships. Okay, and some are one to one relationship. You should be careful. Okay, where you should one, where should keep many here. Okay, then here where you should keep m and one. So one to many or many to one, both are considered as one way, but keep mentioning or writing or placing m and one can be different. That can be in left side some examples. Okay, that can be in right side one example. Anyway, then you can join. You can make all together and finally display the complete ER diagram in this way, right? So previous, I mentioned that repetitively you can build this ER diagram and entities, and then we can extend entities. Then here professor, faculty, and department, and now you can see. Then in this complete ER diagram, it is only contain the things we learned, right? But you have to uh, deeply understand the structure and build and the skill of developing a ER diagram in accurate way. But everywhere, so basically you can see there two entities and one relationship always, right? So from this one and here to here, and okay, then other thing is what? And here to here, and like kind that way. So so and other than when considering these two examples, cardinalities here and cardinalities and and relationships one to one, right? And this here to here relationship, but again one to one, and their cardinalities, okay, can be mentioned as this way. And after that, so like that way you can explain or you can display these things, right? So after that, one by one, then here, then professor can have, that professor already have connection with relationship with department. Then again, you have these one line and professor assigned to department. Got that? So then maybe one professor with one department, or yeah, then you have to mention cardinalities in a accurate way. Previously we have done, then finally you have to connect them in accurate way, right? So look at the way that understood that many-to-many relationship previously we learned as mentioned here, student and classes, many students and many classes. That's why we consider it as many-to-many. And then you can understand many-to-many relationship is there, and you should go through this composite entity related theories. Then and after that, you can build the relationship properly. Got that? Then what you given at the beginning is what paragraph or multiple paragraph explaining there is some scenario or case kind of thing. Then while you are reading, then you should be able to understand where that these kind of many to many applies, or one to one applies, or optional applies. Okay, then it is not directly telling that. Okay, you have to what? Be alert with the given paragraph and information. Then you can carefully draw, right? So, okay, try to draw or understand these sections. Okay, after completing, I will give you another 2-3 minutes for note down, no, understand, no. Okay, then just after understand new thing, you have to note down, no. These are general practices while you are participating day schools or lectures or kind of things. Then after that, we can continue with other presentation. Okay, I will give 2-3 minutes for understand these sections or note down these things. Okay. Then up to related to ER diagram developing. So we already mentioned database structure, converting ER model into database structure, right? So what we have to perform in this section. So what is the important thing you have to understand? The updates and deletions related on the table. Previously, we mentioned that tables are containing multiple records. So they are having relationships. Basically, we have built relationship in between tables by using foreign keys. You know that. When you are deleting some record in one table, you can understand there is effect on other table too. Why? They have relationship. So when there is relationship, think that there are two persons or two tables or multiple tables in a database. So when you break or when you delete or when you remove that one, then other part is getting isolated. Then now you know that in database environment, the users are making queries. Then queries mean asking questions from that database. Then that would be generating an error. Due to what? Problems due to what? Due to these so updates and deletions due to deleting from these tables, right? Hope all of you can understand relationships, foreign keys, right? Records, then relationship types we already know. But then here, so we should be very careful when we are deleting or updating some records in databases or tables, since there may have relationships, right? Presentations upload කරන්න කියලා අහලා තියෙනවා. And මම හිතන්නේ presentations database upload වෙයි ඔක්කොම ටික within මේ ඉක්මනටම and recordings ටිකත් අපි ඉක්මනට upload කරගෙන යනවා හැමදාම. හරි. Okay, then what we were discussing about these relationships and here updating and deleting purposes, how we can perform that. Then there should be some rules. We have to practice some standard method while we are updating and deleting records. So that, okay, we have to go through a proper method. We have to follow a proper method, right? Otherwise, it would be make errors. Inconsistencies we learn. Got that? So, and integrities we learn, right? So, data integrity, consistency, to develop them, we have to go through, to maintain them, we have to go through some specific methods or standards or that kind of recognized actions should be able to perform on the database, on tables, right? So here we consider about some, again, example tables, right? Go through these examples. The painter might have painted many paintings, and you can see here one too many. So then there are some conditions, right? At least one painter should have, must have. Then according to the, yeah, first understand this basic scenario. I will not teach one more, then read and understand. So you can see here the paint is not optional because of must have in condition. You know, painting is painted by one painter in this given according to according to this scenario. So, but here this gallery is optional. So that means a display painting can be done by in gallery. So if exhibiting or displaying that painting, then only in one gallery can be displayed, but it is optional. So this is the scenario. So gallery needs at least one painting, otherwise it would not become a gallery. So they are the things you can go through. And painter number is the primary key, and other attributes, painter information, right? His phone number, and gallery owner, the gallery area code, then gallery phone and gallery rate, and painting. So these are tables we know, right? Then painting number, painting title, painting price, and painting number, and painting gallery number. So you can see some some kind of foreign keys, okay, uh, there, foreign keys, and so painting table contains foreign keys, so gallery number kind of thing, right? And also painting this part contains this point painter number foreign key. So then you can understand so these importances. So then this we mentioned in table format examples, then painters, three painters are here, and paintings. So how many paintings can be are here? Paintings artist then here painting titles. Then you can understand these concepts by going through titles, right? These can okay then say one. So painters here this dias a painter. He has painted about what 1, 2, 3. Okay, multiple paintings, right? Then their prices can be seen here. Then another thing is what? So gallery table. So galleries. Then here there's you can see here that these paintings are displayed in galleries. Here then this 123 painting can it has a gallery number 5. This area in this gallery it has been displayed. Got that? So database relational schema can be displayed as this way. Painter can have multiple paintings. One painter can have multiple paintings, and one gallery is having multiple paintings. So here these are the foreign keys which are including in painting a table to make relationships in between other tables. So previously we mentioned that here we are focusing on how properly delete or update tables here, right? So the properly how here, then we are considering a instance regarding to deleting a record. Go through these things. So just read first. You can read this and understand the concept. And what is going here, you can understand by reading and going through these examples. Very important here. This delete restriction can be formed here. Normally, if we delete painter, that would be affect other paintings and galleries and everything, right? Because of there are relationships. So when user tries to delete a painter from table, then we can what restrictions we have to implement. So if there are no foreign keys, no problem, right? You can delete that. But if there are foreign keys, that means if there are relationships, then you have to be careful that, right? So when user tries to delete a painter, then user should be display warning message. Okay, there is as mentioning as there is a relationship, right? So after that, then database management system, that means the main database software also could be instructed delete all painting rows corresponding to the deleted painter. But we choose not to do so far. The reason just stated. Got that. Again, if you delete them, that would be affect others too. Again, so previously we mentioned deleting scenario. Yeah, then here if you delete, think that if you delete that painted dias. So here again, if we delete this record, look at this one, that paint, then these things also, this one, this painting number would be absent there. Got that? And also these things would be absent. And also these painting tables would be affected then. And also these things that then this one related things would be affected. Got that? But if you delete what? If you delete all the all linked records, what would be thing happen? So this one also getting deleted due to that delete. What would be the thing happen? Then what would be the thing happen if others displayed their paintings in gallery number 5? then there would be a problem. That's why we mentioned that we had to apply some rules when someone tries to delete, some user tries to delete some record. To what? Formalize these required deletions. So then now we know the requirement. Then other thing is adding record to our parent table. Next one. So adding record to our does not cause any problem because the parent tables does not have any dependencies in other tables. So we can easily add with what? New row. Got that. Into parent table. So if you are adding a new painter, then you can 128, then you can enter a painter's information, no problem. That wouldn't be affect other things. So making changes in painter table, primary key values. We read these things and deleting records, gallery table. So read these things, and here just we by using an example, we are understanding what happens when you add or delete or update records in tables. Then after that, how we can learn that, we can understand that how we can apply these conditions or manage these scenarios properly. First, we will understand problems by going through these examples. Okay, then you can understand these examples and making changes in parent table. Here, then it is no problem. And update you can change that parent number or other parent related information, but according to the change user done to paint a table, that would be effect in other tables too if there are foreign keys or relationships. So that is called as this process. Then here this is related to database design, and that is called as update cascade. Right, then here, so this is the summary. Requirement of update cascade means all foreign key references to primary key are updated when primary keys is changes. So this command or this command can be given in some specific areas on the database. Then deleting record from the gallery, you can delete if there are no, you can delete directly if there are no foreign keys. Got that? That means optional. But if there are relationships, so use delete restricted should be alerted to the user. So that should deletions cannot be performed at that stage because of due to the relationships with others. So then delete restrict, you can understand the summary that deletion of the gallery is permitted only if there are no foreign key. And adding records to gallery, no problem. You can add records to gallery, no dependencies. And updating gallery tables, primary key, then again should be careful. Then update cascade clause can be used while you are updating primary key of gallery. Then related table fields or would be update according to the update cascade clause, right? Primary key are not keeping as null. So foreign key are very important. Requirements of foreign keys according to these relationships, one to many, many to many. Both sides mandatory, right? So look at this example. Same kind of example that we have used with previous examples. So many to many relationship again displaying as by using a composite entity can be displayed as this way. And these are the fields, student and enrollment entity fields and class. Three entities can be seen here according to this example. And their fields can be displayed as this way. So these are examples, right? Student, enroll, and classes can be seen here. So previously we learned about some updating, deleting, and restricting kind of things. Okay, then so these sample things. By going through these things, you can understand basic concepts of these given clauses kind of things. We learned about what is delete restrict and what is update cascade, right? Here then class code is behave as the foreign key and student number also behaves as a foreign key here. Enroll table, right? Here we are discussing about enroll table. So foreign key is class code, right? Then we cannot delete a class if contains even one student, right? So to delete class, we must first transfer all of its students into another class. Oh, you can understand. Okay, if we delete, you can understand some data would be getting deleted automatically due to these foreign keys. Then here we cannot delete student, okay, since the if student is only one in the class, then because mandatory relationship, the class must have at least one student. So there are the things you should learn. Take some time and understand these concepts. So okay, student, we can start these, go through these examples and concepts after the break, right? So this would be very important, these sections. And after that, we have to again go through these relational schema, then the way that finally you should, you can map these kind of relational schema according to the given information. We have to cover these things in the next session, right? So after that, also we have to yes, yes, we have to do this one. Okay, then we are going to end the session for now.